name is Sabarish Gurusubramanian, Saba. I'm the CTO for Virya Autonomous Technologies, and we build autonomous mobility in India, right? Virya is a part of the Maini Group, founded in 1973 by Dr. S.K. Maini, and one of India's largest established design and manufacturing houses with companies across a variety of businesses, right? One second, I'm having some challenges with this. Okay, there we go. All right. So I think everyone's heard about the Maini Group, so I'll sort of, in the interest of time, really just go into one piece of history, which is we built India's first mass-produced EV, Reva, back in the day, right? So there's definitely about 5 decades of knowledge and, just experience that's gone into this group, and on that foundation, we've been building Virya Autonomous today. Why am I here today, right? Firstly, thank you to the organizers for the opportunity. There are 4 things I want to touch upon today as we go through this session, right? Sort of on the topic of connectivity, right, which we'll talk about in detail as we go through. We will talk about ADAS, autonomy, everything in the context of India. We'll talk about energy, again in the context of India. But we'll also then talk about how all of these things are coming together, right? There's definitely a lot of synergy between each of these topics. There are a lot of reasons why all of these topics are converging today, and I'll take some of your time today to walk you through that, right? With that, we'll start with connectivity, right? Connectivity is primarily the enabling layer today. I think everyone's been hearing about software-defined vehicles. You've been hearing about what it means to be connected. The early days, it was always about infotainment. A connected vehicle meant you had roadside assistance and, great in-vehicle entertainment, but connectivity is way beyond that today, right? And I think the shift in what connectivity means is moving from a time where connectivity was giving you features inside a car. Now connectivity is what is enabling you to improve the platform over a period of time, right? And of course, we will talk about autonomy as we go downstream. Before I go into a lot of the topics on the future, software-defined vehicles, AI, right? I thought it'll be, a good opportunity to sort of share with the audience here a term that you'll start seeing and hearing about a lot more in the near future, right? You're going to see the word physical AI come up in a lot of different settings, right? Physical AI, in very simple terms, is intelligence embodied in a machine. And this is important for us to understand because we'll be, especially in the next decade, right? Everything we talk about, everything we interact with, there's going to be some element of intelligence that's going to be a part of it. And for all physical systems that we're all working with, this is very relevant, right? In the context of autonomy, it can be right from assistance all the way to fully autonomous vehicles. In the context of electric vehicles, it could just be the intelligence that's going to make these platforms better than where they are today. I represent Virya Autonomous, and I thought this will be a great chance to show you what we built today. So we build fully autonomous mobile vehicle platforms that move material and people, and we operate in controlled environments, right? And this is vehicles that run at low speeds, but by all means are fully electric platforms that are connected. And this is just to give you a glimpse of, where the future is headed. I'm not here to tell you self-driving cars are, around the corner in India right away, but I'm definitely here to tell you that autonomy is very much relevant and real, and it's something that's already running in India today at scale. We have 90 plus robots deployed across factories in India. They're all electric platforms running, in a variety of scenarios, conditions, and we have at least, at this point, 166,000 plus hours of autonomous operations running in India, right? And all of that sort of is possible because we are sort of connecting the pieces of what it means to be software defined, what it means to be electric, and what it means to be a truly connected platform, and sort of piecing all this together to achieve what we're building today. We spoke about software defined platform, right? Enabling something in a vehicle right from day one all the way through its life cycle is what we're trying to do with, calling it a software defined platform. And that requires a fundamental shift in how you think about design, because it's only 20% of the job done when you sell the vehicle. The rest 80% is through the life cycle of the vehicle where you're supposed to, be able to improve it over a period of time. And I think the definition is pretty clear, but it requires a fundamental shift in how we think about building a vehicle, taking existing architecture approaches and then sort of adding the connectivity layer alone will not make something software defined. This requires a lot more ground up thinking. Once you get into something that's software defined, in the context of autonomy and India, right? I think what we really need is assistance done right, and we'll talk about that in a minute in the Indian context, and then we'll talk about what it means as autonomy in India. So when we think about assistance, there's enough of a market penetration today and awareness in the last couple of years, especially with what it means to have emergency braking, lane departure warning, a lot of great features that work fairly well, right, and reasonably controlled environments. Within the Indian highway context, we have better highways now, great lane markings, but the minute you look at these features in the true Indian context, in the majority of the roads that we have today, a lot of things start falling apart. I just wanted to pick a couple of examples, and designing something for India requires a very different mindset shift, right? It's all about our assumptions around the design. Conventional ADAS systems, and I've spent a good chunk of time building these for global markets, work really well when the boundaries of what these systems are well understood and then they're built on top of it, right? We'll take the example of lane departure warning. When we talk about lane departure warning, traditional ADAS systems look at lane markings on the road. They're trying to center you to the lane or keep you within the lane. And this is great when the infrastructure aligns with that, right? But in the Indian context, this is something where we have, everyone that's driven here today will definitely agree with me that we define our own lanes today, right? As much as you want people to follow the rules of the road, we're still very much in an environment where the lanes are actual corridors where people want to drive their vehicles into and not necessarily, where the markings are, right? And that means a shift in how you look at what the drivable space is versus, looking at something within the boundaries of a line. The second part I wanted to share my thoughts on is rule enforcement, right? Most rules of the road, when you talk about traffic conditions, right? There are clear rules saying here's a stop sign, you're supposed to stop before the line by X meters, and you can build autonomous systems that, follow these rules of the road and then deal with a small part of negotiation. In India, every road scene and aspect is all about negotiation, right? Every driver is sort of establishing eye contact with the other driver, you're negotiating who goes in first as you're converging, as you're merging into lanes. And this requires a different shift in how you model and build these systems in the Indian context, right? The third part is what I want to call out as calibrated restraint. And what I mean by that is there's going to be a lot of alert fatigue that's bound to happen when you start, putting in a lot of these different systems in the Indian context, right? When a two-wheeler is riding on a crowded street, there are going to be 6 other vehicles around them. When you're in a car parked in a traffic light, you will have 10 other people walking around you, right? If you start alerting, if you start responding and reacting to every single so-called perceived obstacle or threat, at some point, either drivers are going to turn off these systems or they're just going to be numb to these alerts that you start providing. And this is already, there are enough studies now sort of showcasing how much of an alert fatigue is going to be prevalent as cars get more and more, intelligent when it comes to driver assistance, right? So it's important that we build systems that understand this and we show a lot of restraint, and based on the context of what's around us, then provide the right level of safety, right? The last part, most models that are used in driver assistance systems globally, a significant chunk of how they are trained, how they are, today validated, tested, majority of it is around larger vehicles, larger roads, and of course human obstacles and pedestrians and bicyclists. But in the traffic context, very few systems are, trained with the two-wheeler as a primary actor. And the reason I wanted to bring that up today in this context is when you look at accidents, fatalities, and whatnot in India today, two-wheelers have a big chunk there, right? And the driver assistance systems, the safety systems we build need to be a lot more centric around this. There's some great work that companies in India are now doing with driver assistance for two-wheelers as well, which is excellent. But I think this has to be something that we look at as a shift in how we approach these things, right? With all of this, what I'm trying to get to is in the public road context, there's definitely a lot of meaningful value we can bring in with assistance, but full autonomy, there's a massive opportunity right now in the controlled environment, and which is what we're doing today at Virya, right? You have a bounded space, you're able to operate at lower speeds, and you have control over your actors, right? And you have clear accountability on who the operator is and what the outcomes are. With that, now a different set of challenges arise, because now you have robots and machines that are running in these controlled environments that have to share the floor with humans, right? And the risks there are definitely plenty. We're taking decades of humans that have been operating something of their own, and then we're now introducing robots that can do that. There's always going to be an interaction. There's always going to be a learning curve there. And this is what we should be prepared for as we go through the next few years. And a lot of lessons learned already, right, as we deploy in such environments. A lot of the problem statements that the electric vehicle industry deals with today in wide open spaces and public roads, they all apply to these controlled environments too, except the problem statements are slightly different, specific to that environment. But the minute you bring in the layer of autonomy into these environments, you're dealing with a lot more challenges, right? Operating environments. Operating in rain as a human driver is one thing, to operate as a robot is a very different thing. How do we tackle these challenges? Everything's data driven. So the idea is you understand the environment, you start running supervised deployments, and then you of course expand the envelope of what you're running and where you're running, and then you gradually reduce supervision, right? These are very broad terms, and the reason I kept it broad is this applies to anything and everything related to autonomy, right? You always want to understand what you're trying to do and where you're trying to do that. You want to be doing things in a supervised manner, and then of course you expand, and then you gradually reduce supervision. Now, we've touched upon what assistance means for India, what's happening in the autonomous space, right? I think the key part is the next decade, as we see more and more assistance systems out there, autonomous vehicles out there in controlled environments, as we see everything get completely electric, right? The one key piece that's going to connect all of this is how are we getting data from these platforms, and what are we making sense of from the data from these platforms. And of course, there's a very core theme to why we're all here, which is energy, which is not infinite. And that's, end of the day, going to be the most fundamental problem we'll all probably keep wanting to solve. And how do we use this data to solve that problem, right? On that note, there's a lot of work that within the Maini group we are doing on the energy front. Sun Mobility, one of our sister companies, has done a lot of work on the battery swap space. I'd recommend you go check out Sun Mobility and Indofast Energy and what they do there. But it's pretty clear swapping is a major part of the electric future. We've proven that already, and we're learning a lot more as we do it, right? And when we talk about especially things being connected and autonomous, there's no reason why things should be, sitting for 6 hours, 7 hours charging, right? So the thought here is when all of these things converge and come together, we look at a future where there's no range anxiety, there's no downtime, and we're really just running operations all day long. Today, we may be starting that in India in the controlled environment space, but there's very much a future, 10 years or 5 years, or depending on how fast we get there, where there could be even public road operations that are, very much. So I just want to wrap up with a couple of thoughts. One is the themes you've heard about today. There was a lot of conversation on charging, electrification, specifically infrastructure, batteries, what are we doing? There's excellent work happening on the hardware platforms. I think everyone understands drivetrains. Everyone understands what it means to build the right vehicles, the commercials around it, the policies around it. But I think there's a lot more work we can do here in India in the layer that sits above all of this, right? There's amazing talent, there's amazing engineering depth, And it's important we start more and more building the software layers that define these, the software layers that can enable these, right? When we talk about AI today in every possible aspect of what we do, the magic of what true intelligence can help with when we talk about electrification at scale as a country, I think there's no limit to what we can do. So I strongly encourage everyone to also think about the layer that sits on top of hardware. The software layer is often looked upon as something, as a black box that's done somewhere, it's integrated. I think it's time to shift and break out of that mindset, right? With that, I just wanted to say thank you all for the opportunity.